What is square of a vector? The square of a vector is a scalar whose magnitude is square of the magnitude of the vector. Okay, how is that? Suppose you have got two vectors, say A vector and B vector. One way of multiplying them is through cross product. The other way of multiplying them is through dot product. The cross product, so this cross product will give you the area of the parallelogram formed by the arms of the vector. Area of the parallelogram formed by the arms of the vector. How is that? Suppose A is this vector and B is this vector. Then the cross product A cross B will give you the area of the parallelogram bound by this. Because it's not like something I'm drawing. This vector, copy it and paste it over here, copy this and paste it over here. So these two arms form a parallelogram. Okay, so the area of this parallelogram is what? You get it through this cross product. So this cross product is defined as modulus A vector and modulus B vector and sine theta into n cap. This n cap is perpendicular to both A and B. Here, if this is A vector and this is B vector, this is perpendicular to this plane and comes out of it. Suppose this is x-axis, this is y-axis, the z-axis comes out of the screen. From here, the area of the vector is coming out towards you in the screen. Where this theta, sine theta is, if this is theta, this is called sine theta of them. One example I'll give you. Suppose let's take, this is our x-axis and I'll tell you, this is our y-axis. Let us consider 2 points here, and one point is here at 4 units. So 1, 2, 3, 4. So it's along x-axis. So that is why this point, the position vector of this point is called 4 cap. And let's consider one point over here at 3 units. 1, 2, 3 units here. So this is along the y-axis. So the position vector of this point is called 3j cap. So now if you consider these two vectors, let us draw the vector now. This position vector of point P, let us call this point P, let's call this point Q. Let me just call this point P. This is point Q and this is O. OP vector is this and OQ vector is this. So OP vector cross OQ vector, OP vector cross OQ vector is 4i cap cross 3j cap. 4 into 3, which is 12 into I cross j. Whenever you go from I cross j, k vector is along this axis in the sense z axis perpendicular to this. Suppose this is 4i, this will also form 4i. If this is 3j, this will also form 3j. Now it forms a rectangle. The area vector, the area of this rectangle, the magnitude of the area of the rectangle is 12 and the direction is this way. It is x, y means this is z axis. That means this is k cap. So which is usually 12 k cap. So this is one example. So this rectangle is nothing but a special case of a parallelogram. You see, the square of a vector, the point is, in order to take the square, you have to multiply the vector by itself. So suppose, let us take a vector multiply by the same a vector through cross product. It is a vector is in this direction means another a vector is also in the same direction and on it. So the theta, the angle between them is 0, so that it will not form the area. So a cross a is modulus a into sine 0 degree. That means area bound by the vector multiplied by the same vector through cross product is 0. So it will not form an area. So the value of them will always be 0. So when you want to take a square, you cannot multiply that vector with the same vector through cross product. So what you are bound to do is you are bound to multiply that vector using a dot product. So the second way of multiplying one vector A vector with another vector A vector and B vector through dot product. So when you multiply two vectors using dot product, as a result you get scalar. So it is modulus A modulus B into cos theta. I'll explain what it is. So this A modulus A is simply the number A, modulus B is simply the number B, and cos theta, whatever the angle that you are supposed to do. So how that works? Suppose you have A vector this way and B vector this way. Let us say this A vector has got a value 6 along the x-axis. This B vector is say 2, 3 by coordinate. So it can be written as 2i cap plus 3j cap. That means if you draw a line here, this length of this line will be 2 cap. So this length is going to be 2. So if that is 2, that is along I cap. So when you multiply these two, you will get 6 into 2 as 12, and I dot I is one vector and I is another vector. What you get is I dot I becomes 1. That's what we are going to explain right now. So it is only 12. So it's just a number. Suppose if you don't know whether like 2i cap plus 3j cap, if you know this length is B and if you know this is theta and this is going to be B cos theta and this is A vector which is A, so we multiply it as A into B cos theta. We call this product of A with effect of B on A. So we call this as a product of A with effect of B on A. We call it projection of B on A, B vector on A vector. That's what the dot product is. So dot product is a scalar. Then what is the square of a vector? So we have already found out that you cannot multiply one vector by itself, a vector by itself through cross product, because the result is always 0 because it cannot form a area. But when you multiply the vector by itself through dot product, when you multiply a vector by itself, so A vector dot A vector means it is modulus A cos theta. That means A into cos 0d, because if A is this vector, and another A is the vector on it, okay, it's the same vector, so they make 0 angle with each other. So cos 0, which is 1, cos 0 is 1. So we are getting A square. So whenever you multiply two vectors, A vector dot A vector is equal to A square, which is a scalar. So the square of a vector is a scalar and the square of a vector cannot be a vector, because when you multiply a vector by itself through cross product, because those two same vectors cannot form an area, the value becomes 0, and because the effect of one vector on the same vector is 100%, so its effect on this is 100% A. So this is A, its value is A, the effect of A on A is completely A, that is why the product of which will give you A square. So this is a scalar.